Welcome to Ask and Learn.
We are given languages, and we are asked to find non-deterministic finite-state automatons that recognize each of the languages from this previous exercise, and, if possible, to find an automaton that has fewer states than the deterministic automaton found in that exercise. So the languages are coming from exercise 55. So we have that in part A, our language is simply 0. Now in our deterministic machine, we have that all strings should not be recognized, ended up in the non-final state S2. So in this case, we're going to, again, let S0 be a start state, just as in the deterministic machine. And we're going to suppose that the input starts with a 0. Well, then this string at first should be recognized, so we'll want to move to a final state S1. And so what we have here is now an automaton that's only going to recognize 0. To see why, suppose that the bit at first is a 1. Then we're going to remain at the non-final state S0. In fact, this isn't even necessary. All we really need is just the assignment for 0. And so that is how the non-deterministic automaton is constructed. Now in part B, we are given that the language is 1, 0, 0. In the previous exercise, we made sure that all the strings should not be recognized if they ended up in the non-final state S3. So it follows that this state is not going to be useful for all the strings that are actually recognized by the machine. So instead, we'll have a start state S0 and just as in the deterministic model, we have that S0 is not a final state. And suppose that the first bit is a 0. Then we're going to move from S0 to the non-final state S1. And we have if the next bit is a 0, so we have a 0 at S1, then we'll want to move to the final state S2, and there's not going to be any way out of S2. Now, suppose instead that the first bit is a 1 at S0, then we're going to move from S0 to the final state S3. This was previously S4 in the deterministic model. And once we're here, well, there's no other strings that'll be recognized in the machine that we can build off of this. And so this concludes the construction of our non-deterministic model, which only has 3 transitions. From S0 to S1, input 0. S0 to S3 if the input is 1, and S1 to S2 if the input is 0. Now in part C, we're given that the alphabet is the set of all 1 to the n's, where n is equal to 2, 3, 4, and so on. Now, in the previous exercise, all the strings that shouldn't be recognized ended up in the non-final state S2, except for the empty string. So the non-final state S2 in that example is really not going to be useful for all the strings that are recognized by the machine. So we can remove this from the deterministic model. And so we're left over with a non-deterministic model. So I'll let S0 be the start. And just as in the deterministic model, S0 is non-final. And we see that if we have an input of 1 at S0, then we're going to move from S0 to another non-final state, S1. And if there is a 1 at S1, this string should be recognized because it's going to be 1, 1. And so we'll move to a final state, which we'll call S2, which was previously a different state in the deterministic model. And we see that if we have a 1 at S2, well, this string which has at least 3 ones, should be recognized by the machine. And so we're going to remain at the final state S2.